Welcome, geometry students. We are on lesson 1.4. In our student journals, that's page 19. Let's talk some vocab. You know, we haven't done enough already, so let's do some more. First up on the docket is a polygon. Probably know what a polygon is, or at least maybe you think you do. It is, to be really technical, it is a closed plane figure formed by 3 or more line segments. Okay, so basically what that means, a closed plane figure. All right, so closed implies that there's no gaps, okay? So like, for example, you would have something like this. So this is not closed. See how this line segment doesn't connect to anything? That is not a closed plane figure. So, therefore, it is not a polygon. All right, a closed plane figure formed by 3 or more sides, or segments, we'll say. All right, so think triangle and square and, you know, so 3-sided figure, 4-sided figure, 5-sided, you know, all the way up. That's what we're talking about here. All right, a side. A side is a line segment in a polygon. That's probably the easiest way to describe it. So let me draw a polygon. Let me draw one that's not necessarily what we consider, you know, super common, I guess. So here, polygon. All right, so there's 1, 2, 3, 4, 5-sided polygon. This is what we call a side. So one line segment. So I'm just gonna put a little symbol here and I'm gonna put side. It's probably the easiest way to describe it rather than try to write it in words. But if you wanted to write it in words, I would just say it's a line segment in a polygon. Or if you have a better way of writing it, feel free. All right, a vertex. Well, a vertex is where 2 line segments kind of connect. So it's the point at which, so that point is called a vertex. So there are 1, 2, 3, 4, 5 vertices on this example. So this is what we call a vertex. So basically a point where 2 line segments in a polygon intersect. Okay, and again, it's probably easier just to kind of look at the diagram. That's what we call a vertex. An n-gon. So basically what I want us to remember is that we have names for different kinds of polygons. So I'm gonna go all the way down to the bottom of this page here where it says notes, and I'm just gonna write down some stuff. I'm gonna write down number of sides, and then I'm gonna write down type of polygon. What I need you to be able to do is I need you to be able to understand when I say a word, you need to understand what type of polygon I'm referring to. So if I called something a 3-sided figure, you need to know that that's a triangle. You probably already do, I hope. If it's a 4-sided figure, we call it a quadrilateral. 5-sided figure called a pentagon. 6-sided figure is a hexagon. A 7-sided figure is a heptagon. Hept. 8-sided figure is an octagon. Octagon. Spelled that wrong. A 9-sided figure is a nonagon. And I'm running out of room, so I'm going to extend over here. A 10-sided figure is a decagon. We're going to skip 11. We're going to go to a 12-sided figure is a dodecagon. And then finally, because these are really only the names that we're going to use, so you need to be comfortable with these definitions. If I say something like, oh, draw a dodecagon, that, you know, whatever, that's concave, which we'll get to in a minute. You don't have, you be like, oh, dodecagon. You need to know that that's 12 sides. So as long as you know these types of polygons, we should be good. Anything else we call an n-gon. which n just stands for the number of sides. So back up to our definition, n is the number of sides, so n equals number of sides in a polygon. So technically, we could call a triangle a threegon. we could call a square a fourgon. We have specific names for those, so we don't tend to call them that. But let's say something like a 17gon, which again, we don't really, I'm sure there's name out there for a 17-sided figure, but I don't know it. So we're gonna call it a 17gon. And so basically anything above 12, we just kind of use the number and put gon after it. And that's how we describe the polygon. Makes sense, right? All right, convex and concave. To be honest with you, convex and concave are much easier explained via picture than it is by definition. Convex is probably what you think of when you think of a polygon, like a triangle, maybe your hexagon. These are all closed, a square. So a convex polygon means that basically nothing is kind of caved in. What I mean by that is up here. See how I had this polygon and it kind of darted inside, it kind of went backwards? This would not be convex. This would be concave. It caves in. Convex is like everything's popped out. Imagine like you had a fan in the middle and popped all the sides out. Nothing is kind of caved in. Concave would look, something like this. That's concave. It caves in. This side is not popped out. So again, definition-wise, I just need to know what they are. Convex kind of looks like this. Concave looks like that. So as long as you understand what it is really what I'm kind of getting at here. One other thing I just want to mention real quick is something called a regular polygon. We know regular polygons. Regular polygons are stuff like squares are regular polygons. And what makes a square a regular polygon is that it has all sides are equal, and you should probably know the definition of a square, right? You remember that all angles are right angles. So a regular polygon would be a polygon that's has all the same side lengths and all the same angle measures. For example, this one up here is a 1, 2, 3, 4, 5. It is not a regular polygon. It's still a polygon, but a lot of times when people think of polygon, or pentagon, you might think of the traditional pentagon, right? Where you draw 5, I can't even draw it right now, where you draw 5 sides. 1, 2, 3, 4, 5. Anyway, where they're all equal. This is also called a pentagon. Anything with 5 sides is a pentagon. What is a regular pentagon would be all 5 sides are equal and all the interior angles, all 5 interior angles are equal as well. So just kind of keep that in the back of your head. We'll eventually get to that again. All right, I'm moving on to the extra practice, which is page 20. Actually, no, I lied. We're going to skip page 20. We're going to move on to page 21. So where it says note-taking vocabulary. You're going to do page 20 when I see you in class. So that'll be kind of like practice when you get there. All right, let's do some math. On this one, what I'm looking at is I'm asking you to do a bunch of things. So like, for example, in the first one, number 9 says find the perimeter ABD. So ABD, here's A, here's B, here's D. This is your triangle that we're referring to here. Okay, notice. I'm asking you to find the perimeter, which means I'm asking you to find the length all the way around it. A couple of these lengths are fairly easy to find, like the length from A to B. 1, 2, 3, 4, 5. That's not so hard. That's 5. The length from B to D. Not hard either. 1, 2, 3, 4, 5, 6. Now, a diagonal length, you can't just count squares on a grid. So if it's vertical or horizontal, you can just count the grid, right? But when you're asking for the length of a line segment that's kind of diagonal or doesn't match up horizontally or vertically, you have to do a little math. And so if you notice, This is a right triangle because this is a vertical line, this is a horizontal line, which means this meets at a right angle. And so what we're going to do is we're going to use our lovely friend, the Pythagorean Theorem that I mentioned earlier, and we're going to find the length of this line segment. The Pythagorean Theorem basically says that if I have a right triangle, then I know that the lengths of a squared plus b squared, if you add them together, have to equal the length of c squared. Remember in the Pythagorean Theorem that c is always your hypotenuse, or that longest length. So if I were going to do this, I would call A 5 and B 6. Again, it doesn't really matter. Way you could call it A 6 and B 5. Doesn't really matter. All right, 25 plus 36 equals c squared. This is 61 equals c squared. And then square root of 61 is c. Probably in big ideas, they're going to ask you to write that as a decimal. I don't really like it as a decimal. I like it as just a radical. So this length is root 61. So how do I write the perimeter? If I add 5 plus 6, which is 11, I can't really add a whole number plus a radical. So how you write it is like that. So you would say the perimeter equals 11 plus root 61 units. Now, if you grabbed your lovely calculator and you figured out what root 61 is, it's about 7.81. So 7.81 plus 11 is 18.81. The reason I don't like to use the decimals is because, to be honest with you, it's more accurate to write it like this, because I didn't round. Here I had to round, and so therefore there's error involved. Obviously it's a small amount, but still error nonetheless. All right. Next problem. Find the perimeter of BCD. So BCD, that's this triangle here. So there's a couple ways we can do this. First of all, find the length. Oh, we already know D to B. Remember we did that before, so that's 6. So we need to know this diagonal length and that diagonal length. So what I'm going to do is I'm going to use the distance formula this time. Because it's not a right triangle. Notice that I don't have a horizontal length, but I don't have a vertical length. So I can't use the Pythagorean theorem unless I did a little bit more work here, so I'm just going to use the distance formula. So if you remember the distance formula, you take, so let's do the distance, we're going to do B to C first. So B to C, I'm going to take x2 minus x1, so -1 minus 2, square it, and then add y2 minus y1, so -5 minus -1. Watch all your negative signs because they get a little crazy in here. All right, so the distance from B to C, I get -1 minus 2 is -3. -3 squared is 9. Remember, any negative number squared has to be positive because a negative times a negative is always positive. -5 minus -1. Well, to be honest with you, that's -4. -4 squared, 16. So I get the distance from B to C is root 25, which is 5. Fantastic. Okay, I'm going to do a little more work. Now I'm going to put the distance from D to C. Put a line here. Distance from D to C. Still going to use my lovely formula, the distance formula. So I'm going to call x2 is -1 minus -4 square. And then the y values, -5 minus -1 squared. So -1 minus -4 would be +3, so that would be 3 squared is 9. -5 minus -5 minus -1 would be -4. -4 squared is 16. Notice I get the same answer. So this is an isosceles triangle, just in case you forgot that from middle school. All right, now find the perimeter. Well, that was fairly easy. 5 plus 5 plus 6 is 16 units. All right, now it asks us to find the perimeter of quadrilateral, that's a 4-sided figure, ABCD, which is basically this whole big thing all the way around. So we're going to do 5 plus 5 plus 5 plus root 61. So 5 plus 5 plus 5 is 15 plus root 61 units. Again, you can do the decimal for that, but I like to use regular, non-rounded, so I'm going to call it like that. Next, let's area. Why not, right? Find the area of triangle ABD. So that's that one up here in blue, the one that we did first. It is a right triangle. If you remember the formula for the area of a triangle, it's 1/2 the base times the height. At least that's how I memorized it. And so the base and the height are your horizontal is your base. Your height is your vertical distance. So 6 and 5. So 6 times 5 is 30. Half of 30 is 15 units squared. Find the area of triangle BCD. So triangle BCD is this one down here. And was that isosceles triangle. In order for us to do the area, we need the height. So I need to drop down and find that height, which is 1, 2, 3, 4. So I'm going to do 1/2 the base. The base is always that horizontal distance. So here in this case, it's 6. Your height was 4. 6 times 4 is 24. Take half of 24 and you get 12. And then last but not least, find the area of the quadrilateral. Since we knew this area up here is 15 and this area is 12, all I'm really doing is taking 15 plus 12, and I'm getting 27 units squared. All right, that was fun. Did a little distance formula, did a little Pythagorean theorem, talked some area, talked some perimeter. All right, that's all I have for now. Got any questions you have, come email me or come see me in class. Bye for now.